lesson 1 on page 7. The first thing we're going to do is we're going to review, hopefully this is a review, and hopefully you remember what double number lines are. And double number lines are basically a bunch of equivalent ratios. And so the first thing I want you guys to do is take a look at these two number lines, and I want you guys to fill in the missing numbers on each number line. So you guys need to figure out like what is between 0, what is directly in the middle between 0 and 2. Don't say it out loud. And you can write that number here, and that'll tell you what every number should be on the top line. And then do the same for the bottom line. And then after you're done with that, I want you guys to answer number 2. Now number 2 says, what could each of the number lines represent? So it's your job to invent a situation and label the diagram. So this could be any kind of situation. This could be the relationship between any two different variables. So think about, we talk a lot about relationships between like distance and time, or gallons and teaspoons and years and minutes and all sorts of different units. Come up with a situation and then label these boxes, these dotted line rectangles here, with whatever units you choose. Alright, so I'm going to give you guys about 2 minutes to do this. So fill in the number lines and then come up with a situation that could be represented by these number lines. Okay, ready, set, go. Over this scenario situation? Still thinking? Cool. Okay, and then again, you guys need to answer number 2 and number 3. Situation. Rescue, the ratio of two different things, ratio of dogs to cats. I mean, a lot of different. Okay, let's pause real quick. And I want us to fill in these number lines together, and then I'm going to give you my example of a scenario, because some of you guys are having a hard time coming up with a scenario, so maybe if you hear my example, it'll make more sense. So, first of all, the top number line. What number goes right in between 0 and 2, Morgan? 1, exactly. So we know this is going up by ones on the top number line. So it's 0, 1, 2, and then 3, 4, 5, 6, 7, 8, 9, and 10. So that's the top number line. Now the bottom number line, what is directly in between 0 and 1? Angela?
1.5.
It would be just 1/2, right? 0.5 or 1/2. So I'm going to put it as a decimal, 0.5. And then 1. So then what would be right here, Riley? What would be just to the right of 1? 1.5, yeah, or 1.5, but we'll put it as we'll keep it as a decimal, 1.5, and then it would be 2, and then 2.5, and then 3, and then 3.5, 4, 4.5, and 5. Okay, now I'm going to give you my scenario so it might help you guys come up with your own situation. So here's what I said. I said that these two number lines could represent, on the top I said that this one is going to be time passed, And I'm going to measure time. The units I'm going to use is minutes. So I'm going to say how many minutes go by. And then on the bottom, I'm going to say this is the amount of miles traveled. Okay, so that's my relationship there. So I say the amount of minutes that have gone by has a direct relationship with the amount of miles that have traveled. So let's take this one for example. If I said that it took me 2 minutes to go 1 mile, what kind of transportation am I using? Am I running? Am I walking? Am I bicycling? Am I in a jet? Am I in like a spaceship traveling at the speed of light? What am I using, Nora? What do you think?
I think that you're like biking.
Biking, right? Because it's obviously faster than running. I can't run a mile in 2 minutes. No one can. That's humanly impossible. That would be breaking the world record by a pretty big margin. Even Usain Bolt can't run that fast, and he's a sprinter anyways. So yeah, I would say maybe biking. So if you could go in 2 minutes traveling a mile, that'd be pretty fast biking. Because I know if it was 1 minute per mile, that would be 60 miles an hour. So you'd have to be biking at 30 miles an hour to go this fast. So biking would be pretty fast, but it's possible. Maybe you're downhilling. Maybe Nora probably could. What else? What other kind of transportation? Angela, what do you think?
Horseback?
Maybe horseback, yeah. If you were at a horse like going at full speed, they can definitely run that fast. What do you think, Riley?
A dinosaur?
You could be riding a dinosaur, yeah. Maybe a car that's going like around town a little bit slower, yeah. So my scenario here is I'm going to say that these number lines, they represent let's see, how far I can go on a horse in a given amount of time. All right, now that's my scenario. I want you guys to come up with your own, and it can't be time and miles. Okay, so it can be anything else. But think about all the other units, guys. We can use units like, think about recipes. We can talk about like cups and teaspoons. Think about things like when you go to the grocery store, like when you compare pounds of some sort of produce and price. We can look at time and other things like time and growth, maybe of plants. You can compare two different things like how many cats and dogs you have or something like that. So I want you guys to come up with your own scenario. Give you guys another 30 seconds. Then I want to hear what your scenarios are. Okay, 30 seconds. Ready, set, go. Good, yeah, nice. Ooh, that's a good one. I like it. This is your opportunity to be creative. Come up with a creative situation. Okay, I want to hear some of your scenarios. So, let's hear first from Stice. Let me guess, does yours have something to do with robbing banks? Oh, okay. What is it then?
I just did like chocolate chip cookies, like how many, so the first one's like how many chocolate chip cookies you have, and then the final one is how many chocolate chip, little chocolate things are in them.
Oh, okay. So maybe we could do how many chocolate chip cookies there are and how many tablespoons of chocolate chips there are in individual cookie, right? So 2 cookies has 1 tablespoon or 1 cup of, 1 cup would be quite a bit, but that would work. 1 cup of chocolate chips per 2 cookies. Okay, what else? Riley, what was yours?
Mine was, the top one was like dollars,
Okay.
and then the bottom one was like ounces. So it was like if you go to the grocery store and you buy like a bag of celery
Yeah.
or something, you weigh it, and it's like 1.5 pounds or ounces, and then that would be like $3.
Okay, yeah, so we could say pounds is on top, and what is on bottom is ounces. So maybe it's $2 for an ounce of some sort of good at the grocery store. Does anyone else have another example you guys had? Yeah, Emma, what was yours?
I said like in the recipe, like the cups or something added and the time that it took in the oven.
Oh, okay, so time that took in the oven, that might work, but if we have a recipe, we would typically keep the amount of time in the oven the same. But if a lot of recipes work really well for this. It could be 2 of one thing, maybe 2 cups of flour for 1 cup of sugar for some sort of dough recipe. Yeah, what'd you say, Catherine?
I did like, kind of like that, but it's for 1 cup of flour into like 25 teaspoons of cinnamon.
Okay, perfect. Yeah. So recipes are a really good one. Time and miles. There's a lot of different scenarios we could have here. Some people just said, however many dogs I have to cats. I have 2 dogs for every 1 cat. And maybe if I were to keep getting dogs and cats, I would have 10 dogs and I would have 5 cats. It'd be kind of hard to have 1.5 cats, but that's what they went with. Okay. Yeah, something like that. All right. We're going to go on to the next one. So the next one says, your teacher will show you 3 mixtures. 2 taste the same and 1 is different. So for this one, we are actually, you can follow along with me on page 8. Right here on number 2, it says, here are the recipes used to make 3 different mixtures. Okay? Now I'm going to show you the recipes on on the screen here, but in your books they have them written out right here. Okay? So, here are the 3 recipes, and I want you guys to tell me which one you think is going to taste the same and which ones... So 2 of them taste the same and 1 of them tastes different. All right, so here are the 3 recipes. Now we're talking about powdered drink mix. Now powdered drink mix can be something like, I always think about Gatorade. I don't know if you guys ever buy like the tubs of Gatorade that you just like scoop into water to make your own Gatorade. That's what I use. Some people think about this. They think about Kool-Aid. Yeah, Kool-Aid. Tasty. Lemonade, hot chocolate. A lot of different things we can think about. But we're talking about some sort of powdery mixture that you mix with water. So here's the first recipe. Okay, you guys ready? Here's the first recipe. The first recipe, this person puts 1.5 teaspoons of the powdered drink mix, and he mixes it with 1 cup of water. All right, that's the first recipe. Second recipe is they mix 1/2 of a teaspoon of powdered drink mix with 2 cups of water. All right, and the third mixture is 1/4 of a teaspoon or 1/4 of a teaspoon of powdered drink mix and 1 cup of water. Okay, so I'll go through these again. First one, 1.5 teaspoons of powdered drink mix, 1 cup of water. Second one, 1/2 of a teaspoon of powdered drink mix and 2 cups of water. So notice how you're going in the original recipe, it's 1 cup of water. Second one, it's 2 cups of water, twice the amount of water. But look what happens to the powdered drink mix. It's less powdered drink mix. The third one, 1 cup of water, just like the first recipe. But now we have 1/4 of a teaspoon as opposed to 1.5 teaspoons in the first one. Okay, so I want you guys to work with your shoulder partner on this one. And with your shoulder partner, I want you guys to try to determine which of these 2 powdered drink mixes is going to taste the same. One of them is going to taste different, and 2 of them are going to taste the same. Talk with your tail partners to figure out which ones are going to taste the same. Ready, set, go. No, you tend to distract your tail partner. So I'll be your partner, okay?
Okay, so
What do you think?
I think that the 1/2
I agree. Why do you think that? No, but it's the same thing. I think it's scaled copy, but what are we doing to get from 2 cups of water to 1 cup of water? Yeah, exactly. You're doing the same thing, but 1 half. 1 half of 1 half is 1/4. Yeah, I agree. Sweet jacket. Alrighty, let's go through these answers, and I want to hear from Tyler Richter. What did you and your partner say? Richter is saying that the first and the third are going to taste the same. Why do you think so?
Because the third one has too much water.
Okay, so the third one has too much water, but it has the same amount of water as the first one. And look at this. If they have the same amount of water, and yet the teaspoons of drink mix changes, that to me tells me that the first and third are actually going to taste different from one another. Eden, what'd you say?
We said that 2 and 3 are the same because the third one is just double and then it equals the second.
Okay, I would agree that these two are going to taste the same. Did anyone else decide that these two are going to taste the same? Okay. Here's how Cloud, you had a really good explanation when I was over there working with you. What did you notice? What are we doing to get from the second recipe to the third recipe? What are we doing?
Chopping it in half.
We're chopping it in half or dividing everything by 2, right? So if we have 2 cups of water and we cut that in half, now we only have 1 cup of water. Then, if we have 1/2 of a teaspoon and we cut that in half, that is going to be 1/4. And here's why. Because if we have 1/2 and we divide that by 2, remember, when we divide fractions, when you divide by 2, that's the same thing as multiplying by 1/2. So this is the same thing as saying 1/2 times 1/2. And when we multiply fractions, we just multiply straight across. 1 times 1 is 1. 2 times 2 is 4. So 1/2 of 1/2 is 1/4. So to get from 1/2 to 1/4, we're dividing by 2. So this is kind of like a scaled copy. In the last unit, we talked a lot about scaled copies. You can kind of look at this like a scaled copy. Second and third recipes are scaled copies of one another, so they're going to taste the same. It's kind of like a geometric figure when we were looking at squares or rectangles. They get bigger and smaller, but they have the same characteristics. They have the same ratios. And here's what they look like. Flipping back to the screen, here's what they actually look like. The first mixture, you can tell it's a lot darker, right? So it has a lot more drink mix in it for the same amount of water. Now these two, there's different volumes of them, but the color is the same, so they should taste the same. Does that make sense? So again, we were talking about scaled copies in the first unit. Now we're talking about something that's similar, but they're just equivalent ratios. All right, let's move on. So now we're going to move on to the next page, which is page 9. And on page 9, you're going to see a bunch of different crescent moons. Okay? Now, with these crescent moons, you can see that A, B, and C all look pretty similar, and then D is kind of like the odd man out. D looks a little bit different. So the first thing I want you guys to do on number 1 is I want you to describe visually. So we're not even going to talk about math or numbers right now. I just want you to describe visually. When you look at letter D, how does it look different than the other ones?
Which one do you write down?
And you write that underneath number 1. So how does it look different? Okay, go ahead and just write it down. How does it look different? So you can say things like stretched in a certain direction, or squished, or elongated, or you can look at the curve, and what does the curve do? How is it different? The arc, or the curve. You can look at things like the height and the width of these, of A, B, and C, and how are they different than D? So we're talking just visually. How does it look different? How does it look different? Okay, when you have a good way to describe D being differently visually, raise your hand. I'd like to hear what you have to say. Angel, what did you say? How does D look different?
Because R1 looks like a moon, and B looks like a spaceship.
Okay, yeah, so D looks more of like a spaceship, whereas A, B, and C look more of like a crescent moon. Okay, that's a good way of looking at it. What'd you say, Emma?
I said that like A, B, and C are all like kind of tall and thin, but D's like longer.
Yeah, so we could say that D is, it's not tall and skinny, it's more like squished. So we would say D is, I'm going to use the term shorter and maybe wider. Okay. What else? Cloud, what'd you say?
D looks like a car fell on it.
Yeah, okay, yeah. So D is maybe, smashed vertically. Okay. What else? Catherine.
I said that D is different because A, B, and C, they're like taller, and A is, they're all like equivalent to like 3, I guess, because A is 12 tall from the tip to the tip, B is 6, and C is 3.
Oh, okay. So Catherine's already kind of going on to the next one. She's looking at the height of these, which I think is kind of interesting. And we'll get to that in just a second, so hold that thought. But Sienna, one more thing about how these look differently, or how they look different.
Or B is half as A of the width, and C is half.
Oh, okay. So I like where you're going there. So we'll just go on to number 2. Number 2, we're going to look at we're going to use numbers to describe how they're different. Okay, and to describe how they're different, I hear a lot of people talking about the width. So if we look at A, the width of this is 1, 2, 3, 4. So it's 4 across. Okay, the width of B is 2 across, and the width of C is just 1 across. Okay. That's a good observation. And if we were to measure the height of these, how could I measure the height? What 2 points should I measure between? Nora, what do you think?
The top to the bottom.
Okay, yeah. Brian, what were you going to say?
Yeah,
Just the top to the bottom, maybe like point to point?
yeah.
Yeah, so if we go point to point on A, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I count that right?
Yeah.
4, 5, 6, 7, 8, 9, 10, 11, 12. So this right here from tip to tip is 12. Okay. Tip to tip here is 1, 2, 3, 4, 5, 6. Okay. Tip to tip here is 1, 2, 3. So what is one thing that you notice if I were to look at the width of the moon to the height of the moon? Width of the moon to the height of the moon. What is something you notice there? What is something you notice? Nora, what'd you notice?
For A, you are multiplying by 3 for the 4 to the 12.
Oh, okay. So the width, when we take the width, we multiply that by 3, and that equals the height. Now let's test it on the other ones. Well, the width is 2, multiply that by 3, and yes, that equals 6. Now this one, 1, multiply that by 3, and it equals 3. Yeah, that's an interesting find. So the ratio of the width to the height is always going to be that same thing. We're always multiplying by 3 to get from width to height. Now let's check this other one. The letter D, the odd man out. Well, its width is 3, and its height is 1, 2, 3, 4. Now, if it followed the same pattern, we would have to multiply 3 by 3, but that equals 9, not 4. So that's kind of explains how they're different. Cloud, what else did you notice?
Observation.
What's your observation?
B has the same dimensions, but they're just flipped.
Oh, yeah, that is a good dimension. Or that's a good thing to look at. So I think you're talking about the height to width ratio. It's 3 to 4, and this one is 2 to 6. So it's kind of different. So this one is the width is far less, 3 less, a factor of 3 less than the height, and D, the width is a lot greater, whereas the height only grows a little bit, right? Is that what you're trying to say? Yeah, I totally agree. Okay, so I think we've kind of established that these are different both visually. D is different visually, but it's also different when we look at it mathematically, when we look at the ratio of the height to width. So yeah, I agree. I think that's a good one. Good observations there. All right, so that is it for today's lesson. Now our homework, again, is the lesson 1 practice problems, and we're going to do number 1, number 2, and number 5, and we have just enough time for you guys to get started on that homework, maybe even finish it. Remember, that's going to be due tomorrow, okay? So go ahead and get started on your homework.